So first, we've talked about critical points before when we were graphing derivatives, but we're just going to write this definition out again here. It is where the derivative is 0 or undefined. So 0 numerator or a 0 denominator. And we looked at this when we were graphing derivatives. I remember we did, that matching activity, and you had all those functions that did all kinds of weird stuff like this, and you found all the critical points, all the places where the derivative was 0, and you matched those up on the derivative graph. Those were all the places where the derivative graph touched 0. These are all your critical points. And so those are the candidates for locations of relative extrema. And that just means relative maximums and minimums. So they're candidates. That means they could be the locations of relative maximums or minimums, or maybe not. They're just the candidates for those. Also be careful, it's locations of. The critical points are just the X value. So, and they will like correct your grammar on the AP exam and not give you credit if you don't word it correctly. If you say, X equals 7 is the maximum, they won't give that to you. It's the location of the maximum. If you want the actual value, you have to take that X and plug it in and get Y. So just be really careful with your wording, okay? So here's the first derivative test. If the derivative, if f prime changes from positive to negative, we're going to see what that tells us about the function. So if f prime changes from positive to negative, then that critical point is the location of a relative maximum. If your derivative changes from positive to negative, that critical point is the location of a relative maximum. And do you remember when we did graphing the derivatives and we highlighted, where the function was increasing, the derivative was positive, decreasing meant negative? Do you remember we did above and below sea level? If the derivative is positive, then your function is increasing, and then negative means it's decreasing. So if we change from increasing to decreasing, that's why that ends up being the location of a relative maximum. You get a high point there. And so then I call this like the sibling statement. It's the exact opposite statement. If f prime, so if your derivative changes from negative to positive, then that critical point is the location of a relative minimum. So again, remember the highlighting that we did, where the function was decreasing, the derivative was negative, and then where the function was increasing, the derivative was positive. So this means your graph changed from decreasing to increasing, and so you get a low point. That's why you have a relative minimum at that location. And then I always write this out. This is like your little cheat sheet, and we're going to add on to this next time. Where the original function is increasing, the derivative is positive, and where the original function is decreasing, the derivative is negative. So it all it makes sense logically. It's not like weird or backwards. Increasing, positive, decreasing, negative. So what we're going to do for each of these first two problems is we're going to find where the function is increasing and decreasing, and we're going to find where we have relative extrema, so where we have relative maximums or minimums. And we're going to write out justifications for all of them. So again, it's going to be a little bit of writing, but the justifications are always going to be the same. So if you just drill and practice this, you'll have no problem writing them out on a test. All right, so we're going to need to find the derivative because it's the first derivative test, so we need a first derivative. So this is going to be 3x squared plus 6x, and we are going to set that equal to 0 because that's how we get our critical points. Derivative is 0 or undefined. That would only be if you had a 0 denominator, which we don't have a fraction in this problem. But you're going to just do derivative equals 0 for all of these. If you aren't sure what a question is asking, do derivative equals 0, because that's probably what you're supposed to do. Right, and we're going to factor out 3x. That would leave us with x plus 2. And so we get x equals 0 and x equals -2. And those are your critical points. So that x equals 0 and x equals -2, those are the critical points. So what we're going to do is draw a number line for our derivative. And these are the two factors of our derivative. We have 3x and we have x plus 2. So I'm going to make a number line for 3x and a number line for x plus 2. And we've done this before when we were doing velocity and acceleration. We're going to pick test values. You don't need to work this the whole way out. You just need to figure out if it's positive or negative. Now 3x gave us the critical point 0, and x plus 2 gave us the critical point -2. And notice how I put them on here in order, like from left to right. -2 comes before 0. And so for 3x, if you plug in any number smaller than 0, that's going to be negative. And if you plug in any number bigger than 0, it's going to be positive. And then for x plus 2, if you plug in any number smaller than -2, like -3, -4, -5, that's going to give you a negative result. And anything bigger than -2 is going to give you a positive result. And that's how these are going to always turn out. They'll be negative and then turn positive unless something weird happened. And if you're like, well, what is something weird that happened? You'll know, because you'll be like, oh, that was weird. Like you have an extra negative sign or something squared or like it's written backwards. But if nothing strange happened, they'll always be negative and then turn positive. So I'm going to split my number line into these 3 sections. And so for this first section, everything smaller than -2, I have a negative times a negative, which will cancel and be positive. That's my overall sign for that. And then in between -2 and 0, I have a negative times a positive, which is negative. And then above 0, positive times a positive is positive. I teach these number lines in pre-calc when we're doing polynomial inequalities, and we have to see where it's positive or negative. Does this look familiar to any of you? I teach these in pre-calc, but I'm not sure if everyone's seen them. If you had me, you saw this, but are you guys familiar with number lines a little bit? I just want to get like it's probably going to be a mixed bag, huh? Okay. Do that in pre-calc. Okay, that's okay. Everyone teaches stuff differently. It's totally fine. I do it because I know it shows up here, so people can just get comfortable doing it. But anyway, just you make a number line for each factor in the derivative, and then just put in the pluses and minuses. You don't need to like work it the whole way out. You just need to see if the sign is positive or negative, because the sign is what gives you the information. So here we're gonna write out our statements. There's gonna be a few here, so get ready to do some writing. Heads up. So where the derivative is positive, which would be these 2 sections, the function is increasing. And your statements that you write should always start f of x is, or f of x has. Like this is the function that you're talking about. So we're going to say f of x is increasing on these 2 intervals. So -∞ to -2, union 0 to infinity. Because, and you can abbreviate that, you can abbreviate pretty much as you want, because the derivative is positive there. And this isn't really any different from what we did with velocity. Remember, it was like the particle is moving to the right because velocity is positive there. Is really the exact same thing. It's not any different. We're just calling it f prime instead of velocity. But this is like citing your source. I always say it's like in English, like when you're quoting somebody or doing a bibliography and you cite where you got the information. It's the first derivative test. So f prime is your source that you're citing. Hold on, someone just typed something in the chat. I'm not sure I understand your question. Let me write out the next statement and maybe that'll answer that for you. I'm not sure I understand your question. Let me write out the next one and see if you still have the question. All right, so the next statement, it's going to be like the sibling statement. It's going to be the exact opposite for the exact opposite reason. So f of x is decreasing where this derivative is negative. So that would be from -2 to 0. So f of x is decreasing -2 to 0 because f prime, that's our source that we're citing, is negative there. So in your question, you were asking about like where -1 is. -1 would be in between these, but we're not talking about at a particular point. We're talking about over an interval where the function is increasing and decreasing. Does that answer your question? I'm not sure. I'm sorry. I'm not sure I understand the question. Yeah, okay. Yeah, -1 would be in this section. But again, we're not talking about like right there or at any particular point. It's over an interval. All right, so those are the statements for increasing and decreasing. And then we're going to write statements for the relative maximums and minimums. So again, your statement should start f of x is or f of x has. So we're going to say f of x has a relative maximum at x equals -2. So f of x has a relative maximum at this critical point because f prime, again, that's our source we're citing, f prime changes from positive to negative there. So here's -2. We had to change from positive to negative. So again, that means the graph changed from increasing to decreasing, and that gives you a relative maximum. So where people end up losing points is if they write this statement, x equals -2 is a relative maximum. You can't do that. It's the location. It's the relative maximum is at that location. So please try to write it really specifically like this because they won't give you the points in the AP exam if you have it like written wrong. All right, and then last statement, f of x has a relative minimum at x equals 0. That was our other critical point. Because, so our justification, f prime changes from negative to positive there. So here's 0, and we had to change from negative to positive. Now on the AP exam, they will not read your number line. They won't even look at this. So you have to get good at writing out the because statements because that's the part that they're going to grade. But you can't write these without knowing where your derivative is positive and negative. So you still have to do this work, but what they're going to grade you on is what you've written. So writing the statements is the important part. All right, we'll do one more and then we'll take a break. So this one's given as a graph instead of as an equation, which is nice because we're not going to have to do any of this work. We're just going to be able to write out the statements. So this is the graph of f prime. Be careful because you're not writing statements about f prime. You're writing statements about f, which is not the graph you're looking at. So you're writing statements about a graph that is not this one. This is just the derivative. All right, so first let's just off to the side here list out the critical points, just so that we have those. Critical points are where the derivative equals 0. So this is our derivative. So hey guys, where does this graph equal 0? I'll give you a hint, there's a bunch of them. So maybe just give me one. Let's see if you guys collectively can get them all. There's a bunch of places where this graph equals 0. So what are our critical points? Five and a half would be right here. So I don't see a 0 there. Good, 0 is one of them. We got 0, what else? There's gonna be a few more. All right, 2. Yeah, it's where the, yeah, good, it's where the y value is 0. And 7, I saw somebody write 7, and then good, 4. So there's a lot of critical points here. If you're like, oh my gosh, how many sentences are we gonna have to write? It's fine, you know, we can put some of them together into the same sentence. All right, so first we're going to do increasing and decreasing. So f of x is increasing wherever the derivative is positive. So again, increasing, that's where the derivative is positive. This is the derivative. So this is positive above sea level. So wherever the derivative is positive. So that would be from 0 to 2, and then from 4 onwards. So again, it's where derivative is positive. So that means above sea level. So 0 to 2, and then from 4 onwards, because f prime is positive there. Sorry, my prime ran into everything there. All right, and then the sibling statement, it's going to be decreasing everywhere else for the opposite reason. So f of x is decreasing where the derivative is negative. That would be below sea level. So that's going to be negative infinity to 0, union 2 to 4. Because f prime is negative there. All right, then relative extremes. So relative maximums and minimums. These are the candidates. Okay, so these are the ones that we're going to look at. Let's look at 0. At 0, the derivative changes from negative to positive. It goes from below to above. So hey guys, if the derivative changes from negative to positive, does that mean relative maximum or relative minimum? We went from negative to positive, below to above. All right, good. That means 0 is the location of a minimum, and there is another one. So we can combine both of these into the same sentence. Where is the other, like which one of these other critical points is going to be where we have a minimum? Good, nice job guys, at 4. So at 4, we have a change from negative to positive, below to above. So I can put both of those, 0 and 4, into the same sentence to save myself a little bit of work there. All right, so f of x has a relative minimum at x equals 0 and 4 because f prime changes from negative to positive there. The because part is always going to be the same, and that's why I just kind of drill and practice this. Just write it out, guys. I know it's like annoying, but just do it because you can get so many points on the AP exam for these. Because it's not hard. You just look at where the sign changes, and if you write all that out, they're going to give it to you. So this is an easy way to get a lot of points. All right, and then let's find relative maximum. F of x has a relative maximum at, all right, so we talked about 0 and 4. Out of these ones that are left, 2 and 7, maximum would be a change from positive to negative. So which one of these does that happen? All right, good, thank you. That's going to happen at 2. At 2, we have a change from above to below, so positive to negative. The relative maximum at x equals 2 because f prime changes from positive to negative there. And I'm really sorry, but there is one more sentence because we didn't talk about 7 yet. So we do have to mention that. What's going on at 7? Well, we don't have a change in sign for the derivative. It doesn't change positive to negative or negative to positive. There is no change in sign. So we don't get a relative maximum or a relative minimum there. It's a candidate. Just because it's a candidate doesn't mean that you actually get a relative extreme there. So f of x has neither a relative maximum or minimum at x equals 7. F of x has neither a relative maximum or minimum at x equals 7 because f prime does not change sign there. Some people like to say stays positive there, or if it was below here, they would say stays negative. That wording is up to you. I like to say does not change sign. I just think that's a little bit more thorough. But you could say stays positive as well.